moving on, we're going to look at some subtraction of fractions, and we're going to start with this problem right here. This is 8 4/7 minus 4 1/7. This one is the really straightforward kind. I don't have to do any borrowing. My number 4/7 is bigger than 1/7, so I can go ahead and just subtract. When I am done doing that, it's going to look like this. I subtracted 4 minus 1, and I got 3, so I moved my denominator down as well. My numerator is 3, my denominator is 7, and then I did 8 minus 4, and I got 4. I'm sorry, I almost said 3. I got 4, and so my answer to this problem is 4 3/7. Again, really straightforward, nothing else I have to do. That's one of the easiest problems that your student will encounter. This next one, you can see I've drawn a super long line on it, and I'll explain that in just a minute. Is something that's a little bit more difficult. What a 5th grader likes to try to do with this problem is say, oh, that's 4 1/5, no problem. The problem with that is that I don't have any fifths up here next to this 9 where I can subtract this 1/5 from. Technically what I have is 0/5. I know from my other subtraction experience that I can't do 0 minus 1. I have to borrow. So when I borrow with fractions, it's going to be much like when you borrow with whole numbers. You only are going to borrow from that number that's on the top. So this number on the bottom, 5 1/5, doesn't need to change. It's going to stay exactly the same. I'm going to take one whole number away from this 9, and that's going to reduce it to make it 8. Now we talked about a little bit ago how when we have this fraction that is 5/5, that equals 1. When we have 3/3, that equals 1. When I have 11/11, guess what? It equals 1. Okay? So because I took 1 away from this 9 in order to make a fraction that I could subtract from, I'm going to borrow 5/5. I'm using fifths because this guy down here at the bottom is already in fifths, and at this point in our unit we're only dealing with problems that have the same denominator. So it's an easy change. 8 5/5 is the same thing as 9 0/5. I've just moved some numbers around and made some changes so I can now subtract. So we're going to start here. 5 minus 1 is 4. Again, the denominator will stay the same. That doesn't have to change. Same number of pieces still in our pie. And then I'm going to come back up here and do 8 minus 5, which is 3. My final answer is going to be 3 4/5. This is kind of a tough one for students, and I gave them a second strategy for solving this if they needed it. Here's what it's going to look like if they want to draw pictures in order to solve it. Alright, so you can see that I have represented my 9 0/5 with 9 rectangles. Each one is divided into 5 pieces, and I have shaded in every single piece because I'm talking about 9 holes, essentially. So here's 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, I need to subtract out 5 of those whole numbers. This is one of the few cases where we're going to actually work from the left to the right of the number. I need to subtract 5. Okay, 5 is my whole number, and that's the first thing I'm going to subtract. So I'm just going to cross out. I'm using a different color marker so you can see. 1, 2, 3, 4, 5. Okay, 5 of those holes are gone, and we're not going to pay any more attention to them because we have no need for them. Then I'm going to come, and I'm going to look back at my number, and I have 1/5, which I also need to subtract. So I'm going to come back to this rectangle right here, and I'm going to subtract 1 little fifth from that. Okay? This is what my picture looks like so far. Now these 5 that are up here are gone. We're going to pretend like we don't even see them because they're not part of our equation anymore. The holes that I have shaded in are 1, 2, 3. I haven't touched these. I haven't put any red marks in them. I haven't crossed anything out. So that's going to result in my whole number because the entire thing on all 3 of these rectangles is shaded in. Then I'm going to look back at this little guy over here that is now missing a piece, and I'm going to count how many pieces I have left that I didn't cross out. 1, 2, 3, 4. It's going to come down here and be my numerator. And I'm going to put that over 5 still because this piece is still divided into 5 pieces. It's just missing one. So my answer is 3 4/5. This is how we use a picture to help us solve this problem. And this method is just fine. There's nothing wrong with it. It's just easier for some students to see the visualization of what they're doing rather than just coming over here and using these numbers and borrowing, because this is really difficult for a lot of us. So, again, 3 4/5 is my answer to this second problem. Okay, here's our third kind of subtraction problem that we're going to encounter, and this will be the last problem that we solve today. This video is becoming very long. 10 2/8 minus 4 6/8. Again, you'll notice the denominators are the same, so we can go ahead and subtract, no problem. This number is bigger than this number, so that's not a problem either. The problem that we're going to encounter is that this numerator is smaller than this numerator, which means we're going to have to borrow just like we did in the last problem. Now, as I said last time, when we borrow, just like when we borrow with whole numbers, we're not going to change anything on this bottom number. He gets to stay the same. So I'm just going to write down equals 4 6/8. Okay, that doesn't change. I'm going to come back over to this 10 2/8, however, and I'm going to do some work. Okay, I'm going to take one whole away from that 10, which is going to make it 9. Now in this case over here, I borrowed 5/5 because I was dealing with fifths to begin with. Here, I'm not going to borrow 5/5 because I don't have fifths in this problem. I have eighths, and that's the number I have to deal with. So, what this is going to look like now is 2/8, and now that I've taken 1 away from this 10, we're going to add 8/8 to that 2/8, because that 8/8 is what stands for that one whole that I took away and made this number a 9. So 2/8 plus 8/8 is 10/8. And now, voila, I have numbers that I can actually subtract. So I have 10 minus 6, which is 4. This is going to be 4/8. Again, my denominator doesn't change. And then 9 minus 4 is 5. So 5 4/8 is what I'm going to get for my answer. Now I can come back in and simplify these if I want. I don't have to yet. And I'm going to get 5 because remember, as when we simplified up here, that whole number didn't change. That's not what our goal. Our goal is to make this fraction as simple as possible. If I know a lot about fractions, I know right away that the common factor here is 4. I'm going to divide the top and bottom by 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. So 5 1/2 is the true answer. If your student just wants to put down 5 4/8 for this answer, totally fine. I'm not going to force them to do this yet. We will get to that point, but we're not there today. I hope this tutorial has helped you. If you have any questions, comments, or concerns about anything that we've covered here today, please don't hesitate to give me a call. You can call me at 228-0968 in my classroom, or you can email me at Brinker, that's BRINKER, @d11.org. Have a great night.